Okay, this is the last video to talk about Lewis dot structures, and our very last topic that we're going to look at is drawing Lewis dot structures for an ionic compound. So, as I said just now, we're looking at an ionic compound, but how do we know if we are presented with an ionic compound or not? So, in our very first video, we took a look at what was actually bonded in the chemical formula. So when I take a look at calcium, I'm going to find it on our periodic table. Calcium is located on the left-hand side of our red little zigzag staircase here. If it's to the left of the staircase, that means it is a metal. Chlorine is on the right-hand side, and that is a non-metal. This is what makes an ionic compound. An ion compound is actually going to transfer electrons. And we learned that on the very first day of this unit, but just as a nice little recap. So when we draw Lewis dot structures for ionic compounds, we actually don't need to look at any of the steps that we've been referencing so far. We don't need to calculate any bonds. And I'm talking about the mathematical way to draw a Lewis dot structure up here from your packet. So all this business of calculating how many electrons are shared and how many bonds we need, we don't need to do any of that. So if you can figure out when you're presented with a chemical formula, whether or not something is ionic or covalent, that's going to save you a lot of time. So when it's ionic, we're going to do a couple of other steps. So the metals are going to form cations. And that means that they like to lose their electrons. Nonmetals like to form anions. These guys like to gain electrons. So for calcium, if you look at its valence electrons from our periodic table, calcium is in group 2, so that means it's going to have 2 valence electrons. So I like to draw little dots on the outside to show where we're starting. For chlorine, I'm going to have 2 chlorines, and if I look on the periodic table, they are found in group 7, so they're going to have 7 valence electrons around them. And because we're going to be transferring electrons here, and you don't have to do this every single time, but I like for the beginning just to show where these electrons are going. So calcium likes to lose its electrons, and chlorine is going to like to gain its electrons. So calcium is going to give 1 to chlorine, and I forgot dot here, there we go, and it's going to give the other one to the other chlorine. So when that happens, then calcium is going to form a +2 charge to show that it just lost its 2 valence electrons. And then the chlorines are going to have all the dots around them because they just gained their last electron to have a full shell of 8. So the ions that are going to gain all those electrons, those are anions, they are going to have all the dots around them. The cations that lose their electrons have no dots around them. So if you can figure out that pattern, then that's going to put you in a really good spot for these Lewis dot structures. And that's it. No calculating bonds, no drawing resonance, just showing which ions are going to be gaining and losing those electrons.